Hare Krishna. Good morning to all of my students. So I am going to start. That is the second application. That is the rate measure. The first application we have studied in the last session. That is the tangent and normal. And in that session we have studied how will you find out the equation of a tangent and normal. That is very important. And the second, that is the second application. It is the rate measure. Now what do you mean by the rate measure? Now you know dv by dt. That is the rate of change of velocity with respect to time. dA by dt you have studied in physics. dA by dt, that is the rate of change of acceleration with respect to what your time, isn't it? In the same way, you have to find out the rate of the physical quantity. One rate it is given and the corresponding rate you have to find out with the help of the the rate measure that is given in this chapter. That is the rate measure, isn't it? Suppose the area of a circle it is given, that is area it is equal to pi r square, and suppose they are given as a dr by dt, that is the rate in the radius with respect to time, the rate of change of radius with respect to time they have given. Then the corresponding rate of the quantity which is depend upon the radius, that is nothing but what your area. Suppose you know dr by dt, then you can find out dA by dt, isn't it? That is the rate of change of area with respect to time. That is called as a rate measure, and that we have to study in this chapter, and this is the second application. So this is again very important. Now let us take the first problem here. Again, I want to tell you that again I can't construct such a type of a problem because they have given the points and all this word problem we can't construct. The derivative and the integration we can construct easily, isn't it? But here such a problem I am not going to construct here. Therefore, take the problem in the book, isn't it? Now a particle moves along the curve 6y is equal to x cube plus 2, isn't it? The point on the curve at which y coordinate is changing 8 times as fast as x coordinate. Right, x coordinate. You see, a particle moves along the curve, isn't it? They have given the curve 6y x cube plus 2, isn't it? They have given that is the curve, the equation of a curve. The y coordinate it is changing. The y coordinate is changing 8 times as fast as the x coordinate. Y coordinate is changing means what? That is nothing but dy by dt. This is the rate. It is changing 8 times as fast as the x coordinate. Means what here? This changing as 8 times as fast as the x coordinate. Therefore, they have given, that is the condition they have given, since y coordinate changing 8 times as fast as x coordinate. Therefore, we can write here dy by dt, it is nothing but 8 times dx divided by dt, isn't it? Now again what you have to do? You have to differentiate one with respect to t. Again, differentiate one with respect to t. 6 remain as it is. D by dt of y. Again, here d by dt of x cube plus 2, isn't it? Now again, 6, this constant when multiplied to the function, constant remain as it is. Again, d by dt of y means what here? That is nothing but dy by dt, right? Directly you can find out. Again, what is the derivative of a x cube here? That is equal to 3x square. Take x from here, t from this, you can write as a dx by dt. And the derivative of a 2, that is always equal to 0. Therefore, here you have got 6 into dy by dt, it is equal to 3x square dx divided by dt, because you have to differentiate with respect to t, isn't it? Now, you can substitute the value, that is dy by dt, it is nothing but what here? 8 dx divided by dt. 6 into 8 dx divided by dt, it is equal to 3x square into dx divided by dt. Again, if you observe this, dx by dt get cancelled. 6 into 8 divided by 3 is equal to x square. 3 to the 6. Again, you have got x square, it is equal to 16. Therefore, x is equal to plus minus 4. Right? Now, from this, you can find out because you want to find out what are the point, isn't it? Point on the curve. Therefore, you have got the x coordinate as a what here? Plus minus 4. Now, for x is equal to 4, what is the value of a y? See here, 6y. It is equal to x cube plus 2. Therefore, 6y. 4 cube. 4 cube means what here? 4 cube means 64. 64 plus 2, that is equal to 66. And 66 divided by 6, it is equal to 11. Therefore, the first point, that is 4, 11. Isn't it? Again, for x is equal to minus 4. Again, what is the value of a y? 6y is equal to, again, x cube plus 2. 6y remain as it is. Minus 4 cube. Again, that is equal to minus 64. Minus 64 plus 2, that is equal to minus 62. Isn't it? And y is equal to minus 62 divided by 6. If you divide it with 2, then you will get 31 divided by 3. Isn't it? So, minus 31 divided by 3. So, therefore, the second point, that is the minus 4, minus 31 divided by 3. Therefore, the points on the curve are 4, 11 as well as what here? Minus 4, minus 31 divided by 3. So, this is the rate. They have given what here? Here we want to find out the points on the curve. They have given already the rate of the y coordinate as well as the x coordinate. Their comparison they have given. The y coordinate, it is changing 8 times as fast as the x coordinate. Therefore, dy by dt you can write as a 8 into dx by dt, isn't it? Now, here the equation 1, you can differentiate with respect to t. 6 remain as it is. The derivative of a y with respect to t, that is dy by dt. Again, the derivative of a x cube, that is as usual 3x square, but you have to write x from this and t from this and multiply with dx by dt, because the derivative with respect to t and your function, it is of a x, isn't it? Therefore, first you have to differentiate d dx of x cube into dx divided by dt, right? The derivative of x cube, that is 3x square into dx by dt. Same here, 3x square dx by dt, and the derivative of a 2, that is equal to 0. Then substitute the value of a dy by dt, that is 8 into dx divided by dt. By substituting, you have got the values of a x, that is plus minus 4, and from the values of a x, you can find out the value of a y, right? This is the first question. See, I will take the another one. In physics, you have studied this, that is the rate. The same chapter or same concept, it is in mathematics also. So, it is very simple. Again, the second one, see, a spherical soap bubble is expanding so that its radius is increasing at the rate 0.02 centimeter per second. At what rate is the surface area increasing when its radius is 5 centimeter, isn't it? Very simple question. Here you should know about the mensuration. You should know the volume of the sphere, volume of the cone, the volume of the any three dimensional. Now, how will you find out the volume of any function, that is the any quantity here, physical quantity? The general formula, it is given as a area of a base into height. In this way, you can find out the volume of the any three dimensional. Suppose you want to find out the volume of a parallelepiped. How will you find out the volume of a parallelepiped? The base is rectangle, isn't it? There is a height, and again the volume you have to find out the area of a base into height. Suppose you consider the base, it is what here, the parallelepiped, the base is rectangle, isn't it? The base is rectangle. Therefore, what is the area of a rectangle? Length into breadth, isn't it? Therefore, L into B. And again, you have to multiply the height, that is the area of a base into height, means into H. Therefore, L into B into H, it is nothing but the volume of a parallelepiped, isn't it? Suppose you want to find out the volume of the cylinder, isn't it? The volume of a circular cylinder. This is the cylinder, and suppose we want to find out the volume of a circular cylinder. Now, the base is what here? Circle. The base is circle. Area of a base into height, and suppose the height is H. What is the area here? Area of a circle, that is equal to pi r square, and into height, it is nothing but the volume. In this way, you can find out the volume of any three dimensional, isn't it? So, whenever you have to find out the any three dimensional figure, then the general formula for finding the volume, that is the area of a base into height, isn't it? Now see, and the physical quantity, that is you have studied in the mensuration, and that is in a 10th standard. Now, spherical soap bubble means you have to consider what your sphere. You have to consider a sphere. A spherical soap bubble is expanding so that its radius is increasing at the rate 0.02 centimeter per second. Means they have given the rate of what here radius, let R be the radius of a sphere. Then they have given as a dr divided by dt, it is equal to 0.02 centimeter per second, isn't it? At what rate the surface area is increasing? At what rate the surface area, let S be the surface area of sphere. What is the surface area of a sphere? You have studied in 10th standard. So, S is equal to 4 pi r square. This is the surface area of a sphere. And if we want to find out at what rate is the surface area is increasing, means you have to find out ds divided by dt, isn't it? It's again very simple. And the radius they have given as a 5. See, when the radius is 5, at what rate the surface area of the spherical soap bubble, that is the surface area of the spherical soap bubble, is increasing, isn't it? Therefore, again very simple, differentiate with respect to t, right? Then again ds divided by dt, the 4 pi constant remain as it is. When the constant, it is multiplied to the function, constant remain as it is. Again, as usual, the derivative of a r square, that is equal to 2r, and multiply with dr divided by dt, isn't it? Therefore, ds divided by dt, this is 8 pi, the r it is given as a 5, and the dr by dt they have given as a 0.0, isn't it? Therefore, here 8 5s are 40 pi into 0.02. Again, you have got that is 80, and you have to give the decimal point after 2 digit here, because here 0.02 into 40. Again, this 0 remain as it is. Again, 4 to the 8, isn't it? 0.8 or 0.80 pi, you can say. And since this is the surface area, this is the surface area S. Therefore, since this is the area, you have to give the unit, that is the centimeter square per second, since this is the area, isn't it? So, the surface area is increasing at the rate that is 0.80 pi centimeter square per second, right? This is the very simple here. Another one I will take. See, very simple problems are there. Rate measure. See, the surface area, third one. Surface area. Surface area of spherical balloon, of spherical balloon is increasing at the rate of 2 centimeter square per second. At what rate? At what rate? Volume of the balloon is increasing. When radius of balloon is 6 centimeter. Again, very simple. The surface area of the spherical balloon is increasing at the rate of 2 centimeter square per second. Means they have given the rate of what is surface area. Therefore, let S be the surface area of spherical balloon. Therefore, by given condition, ds divided by dt, they have given as a 2 centimeter square per second, isn't it? Also, they have given the radius. The radius, let r be the radius of spherical balloon, where r is given as a what here, that is 6 centimeter, isn't it? This is given. These are the information given in the problem. What you have to find out here, that is at what rate the volume of the balloon is increasing. Means to find here, what do you want to find out? To find dV divided by dt, isn't it? Now they have given the surface area. So what is the surface area of the sphere? आत्ताच बघितलं आपण 4 pi r square, isn't it? They have given ds by dt. Therefore, differentiate with respect to t, isn't it? Again, ds divided by dt. 4 pi remain as it is. The derivative of a r square, that is 2r into dr by dt, isn't it? They have given 2 into 4 pi into 2. What is r here? R, it is equal to 6 dr by dt, right? Again, 2 to get cancelled. Here you have got, that is 6 4s are 24 pi, it is equal to dr by dt. Here you have got dr by dt, it is equal to 1 upon 24, isn't it? Now again, we want to find out, that is what here, dV by dt. Therefore, what is the volume of a sphere? See, what is the volume of a sphere? You have studied in mensuration. What is the volume of a sphere? That is 4 by 3 pi r cube, isn't it? Again, we want to find out dV by dt. Means here 4 by 3 pi remain as it is. The derivative of a r cube, that is equal to 3r square and into dr by dt, isn't it? Again, very simple. This get cancelled. dv by dt, it is equal to 4 pi. Again, what is the radius here? The radius, that is 6. 6 square, and again dr by dt, it is equal to 1 upon 24 pi. Right? Again, if you observe this, pi get cancelled. 6 into 4 into 6 divided by 24. Again 6 4 ja 24. 24 get cancelled. Again 6, isn't it? Since this is the volume, therefore dv divided by dt, it is equal to 6 centimeter cube per second. Therefore, the volume is increasing at the rate of a 6 centimeter cube per second, isn't it? Now the next example, I will take the fourth one. See, fourth. It's very simple examples are there. Some rate is given and you have to find out the another rate which is depend upon that physical quantity, isn't it? So it is quite simple. And whatever the information given in the problem, that we have to write down, isn't it? So see another. If, fourth one, if each side of an equilateral triangle increases at the rate of root 2 centimeter per second. Find the rate of increase of its area when its sides side of length 3 centimeter. You see, very simple. If each side of an equilateral triangle increases at the rate of root 2 centimeter per second, you have to find out the rate of its area. Again, very simple. Let x be the side of an equilateral triangle. Isn't it? And its rate they have given, that is dx divided by dt, it is equal to root 2 centimeter per second, isn't it? Let A be the area of an equilateral triangle. To find dA by dt, where x is given as 3 centimeter. Again, what is the area of equilateral triangle? The area of equilateral triangle, it is equal to root 3 by 4 into side square, isn't it? Therefore, A is equal to root 3 by 4. What is the side they have given? X. Therefore, this is x square. Again, differentiate with respect to t, dA by dt. It is equal to root 3 by 4. The derivative of x square, 2x, and multiply with dx divided by, isn't it? Again, dA by dt remain as it is. Here, 2 get cancelled. Root 3 by 2 into 3, because the value of x, that is equal to 3 they have given, and dx by dt again root 2, isn't it? Therefore, this you can write as a 2, you can write as a root 2 into root 2. Therefore, 1 root 2 get cancelled. Therefore, here you have got that is, or you can write also, this is 6 root 3 into root 6 divided by this, or otherwise you can write 3 remain as it is, root 3 remain as it is. Here you can write anyway you can write yourself, but this is the centimeter square per second, since this is the area, isn't it? So very simple one. Or also you can write like this, असं पण लिहू शकता तुम्ही, root 6 divided by 2 centimeter square per second. Anyway you can write, isn't it? So this is again very simple. They have given the rate of the side and you have to find out the rate of a area, isn't it? So the area, you know, the area of a equilateral triangle, that is root 3 by 4 into side square, means x square. You have to differentiate with respect to t, dA by dt. It is nothing but root 3 by 4 remain as it is, and the derivative of x square 2x into dx by dt. Substituting the values, you will get the result, isn't it? Very, very simple examples are there. So I will take the fifth one here. Fifth one. See. The volume of sphere increases at rate of 20 centimeter cube per second. Find rate of change of its surface area when radius is given as a 5 centimeter, isn't it? Now again they have given the volume of a sphere is increases at the rate of, let V be the volume of a sphere, isn't it? Again they have given dV by dt, it is equal to 20 centimeter cube per second, right? You have to find out the rate of change of surface area. But here, what is the volume of a sphere? The volume of a sphere, that is 4 by 3 pi r cube, isn't it? Now you can differentiate here. dV divided by dt, it is equal to 4 by 3 pi, and this is 3r square into dr by dt. The derivative of r cube, that is 3r square, and into dr by dt, isn't it? So what is dV by dt? 20, and here 4 pi. What is r? They have given 5 square dr by dt, isn't it? Therefore here again, this is 25. 25 into 400. Therefore 20 divided by 100 pi, it is equal to dr by dt. Again 25 is, therefore 1 upon 5 pi, it is equal to dr by dt. Got it? V is equal to 4 by 3 pi r cube. dV by dt, 4 by 3 remain as it is, pi remain as it is. The derivative of a r cube, that is 3r square, into dr by dt. They have given dV by dt, that is equal to 20. Again 4 pi remain as it is, but the radius they have given as a 5, means this is 5 square, that is equal to 25. 25 4 ja, it is nothing but what here, 100. 100 pi into dr by dt. Therefore 20 is equal to 100 pi into dr by dt. Therefore dr by dt, it is equal to 20 divided by 100 pi, means here 25 is 100. Therefore 1 upon 5 pi dr by dt. This is number 1. But we want to find out the rate of the surface area. Therefore surface area of the sphere. Therefore again, what is the surface area of a sphere? S is equal to 4 pi r square, isn't it? Now ds divided by dt, it is equal to 4 pi. The derivative of r square, that is 2r into dr by dt. Again this is 8 pi. R means 5, and again here dr by dt, that is equal to 1 upon 5. Right? 5 get cancelled, pi get cancelled. We have got that is 8 centimeter square per second. Isn't it? Therefore, here you have got that is the rate of the surface area. It is equal to the 8 centimeter per second. Very simple one. Again, another one. Very simple problems are there. Only you have to find out one rate is given and you have to find out the corresponding rate. Isn't it? Sixth one. The age of a cube increasing, decreasing at the rate of 0.6 centimeter per second. Find the rate. Find the rate at which its volume is increasing. Its volume is increasing. Its volume is decreasing. Decreasing. When age of cube is 2 centimeter. Isn't it? Now again, the age of the cube is decreasing at the rate of, therefore consider let x be the age of the cube, means side of the cube, age of the cube, or you can say side of the cube, isn't it? Or side of the cube, isn't it? Now again, dx divided by dt they have given, that is the age of the cube is decreasing at the rate of 0.6. Since it is decreasing, you have to take the rate minus centimeter per second. Since this is decreasing, you have to take the rate as a minus. Find the rate of the volume, means to find what here? dV divided by dt, isn't it? Again, x it is given as a 2 centimeter. Now what is the volume of the cube here? All the sides are same here. Therefore, length into breadth into height, x into x into x. Here you have got the volume that is equal to x cube, isn't it? Again, differentiate with respect to t. So, dv divided by dt, it is equal to 3x square dx divided by dt, isn't it? Now again, very simple. Here they have given, that is 3, x they have given as a 2 square, and again they have given minus 0.6 dx by dt, isn't it? So this is 4 3s are 12, 12 6 minus 0.6. This is 72, 6 2s are 12, 2 1 carry, 6 1s are 6, isn't it? Again this is the 7.2 because that is the 1 decimal here. You have to give the point after 1 decimal, isn't it? After 1 digit, and this is minus. Therefore, the volume it is decreasing at the rate of what here? 7.2 centimeter cube per second. Now, whenever you write in the form of a word, then you have to write it is decreasing at the rate of what here? 7.2 centimeter per second. But when you use the word that is increasing, then you have to write that is minus 7.2 centimeter cube per second, right? So when you use the word decreasing, then you have to eliminate this minus sign, and when you use the word increasing, then you have to give the minus sign. That is the difference, and at last you have to write, isn't it? So here I have finished some example on the rate measure, and in the next session also I am going to take the rate measure and again continue the another application, isn't it? So the student, if you like my video, then share it and subscribe my channel. And again, you want to give me the suggestion, please give me the suggestion. Again, any details you want, then also you can comment it and tell me, isn't it? So good day for you.